Assalamualaikum and very good day to you, Doctor. Today our group will present about safety helmet. First of all, I'm Muhammad Faiz bin Yusof. We will explain on how to select the best material for this product. During the material selection strategy, first step we need to do translation. Translation we need to do the based on the design requirement, the function, constraint, free variable and objective. From this information, we can derive the material index for this product that will be used for the next stage where screening. During screening, we will use material index to shortlist the material based on their ability. Material with highest material index will be selected for the next step where is ranking. During ranking, we will do scoring method to the material that have been shortlisted based on their attribute and properties. The material with highest score will be selected, and based on our study, we found out that polycarbonate have got the highest score during ranking. So this material will be choose for the safety helmet. And for one more information that is polycarbonate have the highest score during polycarbonate also have the highest material index value. So this material is really suitable for this product. And the final stage of material selection is to do documentation, where we will do documentation to find out further information about the material that have been selected and give more information about the characteristic of the material that make it suitable for the product. Next, we will proceed for process selection strategy to make safety helmet.
Thank you, Mama Faiz. Now we're gonna take a look at process selection strategy. Okay, for the process selection strategy, it consists of three methods, which is shaping, joining, and finishing process. And all of this process is important to choose at early stage to prevent larger cost penalty. And it depends on design requirement and demand for the product. Okay, so we're gonna take a look. Okay, for classification, to make the process selection strategy easier, we make it into classification from family to class to member and to attribute. Okay, we're gonna take a look one by one. Okay, first, for the shaping process, okay, we choose the injection molding process because of its attribute that follow the design requirement, which is to minimize cost. Even though for its tooling is quite high, but the cost modeling for making it into mass production is low. Okay, so for joining process, the snap fit is used to join the headbands because based on the attribute, the headband can be joined in the geometry, which is lap, sleeve and scarf. In this case, the headband is in lap geometry, thus it can use snap fit, which is more compatible to use it. Okay, for the last process, which is finishing process, it use coating class and polymer powder coating because of the material used for the helmet, which is polycarbonate that come from the polymer family, and it also has lots of function for the treatment, and the costing for it is low. Thank you. Now we're gonna take a look at manufacturing process.
Hi, my name is Adira. I will explain the manufacturing process of the safety helmet. The method that being used are shaping, joining, and finishing. The injection molding has been chosen and is the most commonly used for fabrication of plastic part. The example of the processing parameters are cycle time, cooling time, injection speed, and injection pressure. The machine consists of two main parts that are injection unit and clamping unit. The equipment at the injection unit are the hopper, barrel, reciprocating screw, heater, and nozzle. Meanwhile, at the clamping unit there are mold cavity, mold core, clamping motor, ejection bar, and ejection system. The procedure are clamping, injection, dwelling, cooling, opening, and ejection. Next is the joining process. The process that been chosen is snap fit. The process parameters are height modulus and height cross-sectional. Lastly, the finishing process. There are the polymer powder casting. The parameters are the weight of polyethylene, weight of distribution, and the length of side chain.
Hi guys, my name is Nur Nabila and I would like to present about flowchart for production process. Okay, the process is begin and then the shell is selected according to the shape that we want to produce. Then the form is positioned in the injection molding press. Then pellet colorant will mix with the polycarbonate pellet, which is the material that we use to produce a safety helmet, and then the molten plastic will inject into the mold. Then the press machine is used to open the mold when it's cooled down. After that, other components for suspension system are produced, such as headband and plastic key is used to attach it. Besides that, nylon strap and gears are used for ratchet mechanism. Brow pad is attached to the front of the headband. Then both ends of the headband strap are inserted into the ratchet mechanism. After that, powder coating process is occurred to make a better surface finish of the product. Then testing and quality control has been done to check whether the safety helmet fulfill the requirement or not. If not, the safety helmet will remelt again and form a new safety helmet. The process is complete when the safety helmet are produced. Next, I will pass to the next presenter. Thank you.
I'm Khairul Ikhwan. I'm going to explain about the effect of manometer on the safety helmet performance. As the other members explained earlier, each process have their own parameter that need to be considered. For the example, for the shaping process, which is the injection molding, the parameter that gives the most significant effect to the performance is mold and make temperature, since the material used is polycarbonate. In mold temperature, it is affecting the cooling injection part, because the higher mold temperature will reduce the cooling speed of the skin layer, resulting more uniform cooling through the thickness. For the joining process, which is the snap fit, the parameter that can give effect to the performance is modulus of material and cross-sectional moment of inertia. This is because the low modulus of material and moment of inertia can be easy to break down, since it can be bent or be forced out of the shape. For the last process, which is the polymer powder coating, the parameter that can give if most effect to the performance is weight of polyethylene. This is because the ultra high molecular polyethylene is an extremely difficult material to coat with, as it is rubbery and chemically very inert. For the crystallization, this parameter also can give the strong effect in terms of material properties. This is because the increasing of crystallization will increase the hardness and the density of the material. That's all for me. Next, we proceed to the quality control.
All employees working in areas where there is a possible danger of heat injury from impact or from falling or flying objects or from electrical shock and burns shall be protected by protective helmets. To make sure the helmet is safe and good for the worker to use, there is a few tests that need to be run under the EN 395/1995 Clause 5 performance requirements, where the first test is shock absorption. 5 kg round metal object is dropped onto the helmet from a height of 1 meter, which is the same as 49 joule. Test is passed if force transferred to head form less than 5 kN. The second test is resistant to penetration. A 3 kg sharp edge object with 30-degree drop from a height of 1 meter, which is correspond to 29.5 joule. The striker is not allowed to touch the head form. Next, flame resistant test. The helmet needs to be held on the burner for 10 seconds. Then, 5 seconds after removing it from the burner, there should no longer be a flame burning on the helmet.
Okay, this is the defect and countermeasure to manufacture the safety helmet according to the related processes. Okay, first, for shaping process, which is injection molding, the defect that may be occur is shrinkage or sink mark. The defect is caused by the shrinkage that result from the slow cooling of surface of the thick wall as shown in the picture. The countermeasure for this defect is, first, we can reduce duration of the thickness. Second, we can increase injection pressure. And third, we can raise injection capacity. Second, for joining process, we use net fit process. Okay, the defect that may be occur for this process, which is stress concentration. This defect is caused by sharp corner concentrate stress on the cantilever root, which make it more susceptible to shear off. To overcome this problem, the countermeasure for this defect is we had to add a fillet to the cantilever base to reduce any stress concentration due to the sharp corner as in the picture. Last, for finishing process, we use polymer powder coating process. The defect that may be occur from this process is round and sag. This defect is caused by the temperature is too low for adequate the operation of the solvent, or too much humidity in waterborne paint. To overcome this problem, or the countermeasure for the defect is we need to adjust the spray piston and apply thinner wet coats. If a paint is a waterborne, apply the paint in a low humidity environment. As the conclusion, we use polycarbonate material as the to manufacture our product, as the material meet the design requirement, and the process also is suitable to manufacture the safety helmet.